Hello, today we're looking at section 9.2, how to use the graph of a quadratic equation in order to solve it. So in the last chapter, we solved quadratic equations by factoring, but there were certain times where we couldn't solve because our quadratic function was prime. We couldn't factor it. So graphing is another method that allows us to solve every equation, whether or not it can be factored. The big idea behind today's lesson is that once you graph a quadratic function, once you create that parabola, then to find the solutions, the answers to your equation, you look at the x-axis. You find the x-intercepts. They are the roots, the zeros, or the solutions to your equation. And all of those words are synonymous. The answers, the solutions, the roots, the zeros all mean the same thing. When you graph a quadratic function, there are three different possible solutions that you'll come up with. And those are the three pictures here. The first one is where you end up with two roots or two answers, because this graph touches the x-axis at two different points. Remember, our roots or our answers are where the graph cross over the x-axis. The other option is that you end up with just one answer or one root, and that's where your graph touches the x-axis at only and exactly one point, like this one. And the last option is where you have no roots, no solutions or answers. And that happens when your graph does not cross the x-axis at all. So notice this graph stays completely above the x-axis. And most of the work for today's lesson will be to just create the graphs. And then once you have your graph, you're identifying how many roots are there, and what are those roots. So take a look at question number 1. It says, solve the quadratic equation by graphing. If integral roots cannot be found, state the integers between which the roots lie. So that just means if your answers aren't whole numbers, tell me between what two numbers the answers would be. So if it looks like the answer is like 1.5, say somewhere in between 1 and 2. Okay, for all these questions, notice now we're looking at equations instead of expressions. So we have our equal signs. We want to make sure that our equations are in standard form. Then we do the same thing we did for the last lesson. We're going to start by identifying A, B, and C based on our given problem. So in question number 1, A, the coefficient for x squared, is just 1. B, the number in front of x, is 7. And C, the constant, is 12. Then find the axis of symmetry. So we use our formula, x equals negative b over 2a. So here that's negative 7 over 2 times 1. Negative 7 divided by 2 makes our axis of symmetry, x equals negative 3.5. Okay, that's the x-coordinate of our vertex. So that becomes the center number in our table of values. So here I'm going to put my negative 3.5. Choose two numbers below that. So negative 4 and negative 5. And then choose two x values larger. So that would be negative 3 and negative 2. Okay, we then take each of these x numbers and plug them back into our original equation to find the matching y value. For the sake of time, I've already found those ahead of time, so I'm just going to fill in our chart here. 2, 0, negative 1/4, 0, and 2. Then each row becomes a point that we're going to graph. So this first row becomes the point negative 5, 2. Then we have negative 4, 0, negative 3.5, negative 0.25, so we're in between boxes, negative 3, 0, and negative 2, positive 2. So we create our graph exactly like we did last week. And then the only new part of this is to determine how many answers we have and what those answers are. So our solutions are where the graph crosses over the x-axis. So if I take a look here, this graph touches at 2 points, these 2 points. Those points are at negative 4 and negative 3. So my roots, or my answers, are x equals negative 4 and negative 3. I can also verify that based upon my table of values. If the roots are where they cross the x-axis, remember our y value has to be 0. If we're sitting on the x-axis, we haven't moved up or down at all, so we have a y number of 0. So here we have our 2 roots, and they are at negative 4 and negative 3. When you flip over to the back, take a look at question number 2. So we're going to do the same exact process. When you look at question number 2, we have standard form again. So start by identifying A, B, and C. Here, A is 1, B is negative 4, and C is 5. Find the axis of symmetry, which has the formula x equals negative b over 2a. For this question, that's negative 4 over 2 times 1. That's positive 4 over 2, or x equals 2. So that's the x-coordinate for our vertex. That's the center point in our table and on our graph. So I have an x value of 2. Choose 2 values below that, so 1 and 0, and 2 numbers above, 3 and 4. Then we plug each of these values back into the original equation to find the matching y value. When we do that, ignore the equals 0 part. I forgot to say that in question number 1. So for example, when I plug in x is 0, I'm just going to do 0 squared minus 4 times 0 plus 5. And that would give me the y value of 5. When I plug in 1, I'm looking at 1 squared minus 4 times 1 plus 5, which gives me 2. When x is 2, y is 1. When x is 3, y is 2. And when x is 4, y is 5. So I just continue plugging in the x values to find the matching y. Now plot each of those points, so you should have 5 points. Okay, like last week, try to make it look like a U shape, put those arrows on the ends. And the new part of today's lesson is then once you have your graph, checking to see how many times the graph crosses the x-axis and at what values. So this graph is never going to cross the x-axis, therefore this has no roots or no solutions. And let's take a look at one more example. In question number 3, our equation is not in standard form. So we're going to start by adding 4 to both sides of this equation to put it in standard form. so that we have x squared plus 4x plus 4 equals 0. Now our A is 1, B is 4, and C is 4. So we find our axis of symmetry, x equals negative b over 2a. That's negative 4 over 2 times 1. So our axis of symmetry, the center of the graph, is at x equals negative 2. That becomes the center of our table, as it'll be the center of our graph. 2 x values below that, negative 3 and negative 4. Then I choose 2 x values above it, negative 1 and 0. Plug each x value into your equation in standard form. So you're going to plug back in here. Okay, again, I did that ahead of time, so our y values will be 4, 1, 0, 1, and 4. Then we create our graph by plotting those 5 points. Connect the dots, try to make the U shape, arrows at the ends. And then our final step is to look at where the graph crosses the x-axis. This graph hits the x-axis at exactly 1 point. That 1 point has an x value of negative 2. So there's one answer, one root at x equals negative 2. Again, we can verify that from our table of values. The roots will always have a y value of 0. Okay, please make sure that you complete the homework attached with